Good morning. I'm going to talk about the last law of exponents. We've already talked about the distributive property. We've talked about adding and subtracting and combining like terms. We've talked about multiplying and how when you multiply, you add the exponents. We have also talked about dividing the coefficients, subtracting the exponents, the zero power, which means that it equals 1, and negative exponents, which basically mean they're in the wrong place. There is one more property that we need to talk about, and if you don't have this part written down already and you're in my third block class or second block, you might need to write that down. But anyway, the last property is pretty important, actually. It's often called the power to a power property. And with the power to a power property, it would look something like this. X to the a, and then the whole thing to an exponent itself. The rule is that you multiply them. So it's going to be x to the a times b. And I'll give you an example in just a minute. So we'll say multiply exponents. All right. So let me give you a couple examples first, and then we will do some examples for everyone of everything. So we'll just have a page here called power to a power. So I can show you the example since we didn't have a chance to do the station about those. So example number 1. Kind of wrote that weird. But we have a squared and then that whole thing to the third power. So you're going to do a to the 2 and multiply the exponents. 2 times 3. So the answer is a to the 6th power. As you are watching these videos, if you find that I'm going too fast, then just pause it or rewind it so you can watch it at the pace that you need. Another example. So we want 5a squared twice. That's why we have the extra squared. Just to show you why it works, this means 5a squared times 5a squared. That's what it means. We have two 5a squareds. So we would multiply 5 times 5 is 25. A squared and a squared would be a to the 4th. That's the answer. Okay, but using the power to power rule, we would be giving basically kind of like distributing the exponent on the outside to the exponents on the inside. The 5 has an imaginary 1. So the shortcut way to do this would be to do 5 squared, and then a, 2 times 2 is 4. 5 squared is 25, so 25a to the 4th. Doing it this way is fine with a small problem, but with a big problem, with big exponents, it gets to be a lot of work. So we use the power to power rule in order to do it shorter. For example, it would be a lot of work to write this out 3 times. And can you imagine if this was like a 10? That would be a lot of work. So we're going to use the power to the power rule and multiply the exponent on the outside by each of the exponents on the inside. Again, remembering that the number in front has an imaginary 1 exponent. So it really means 2, 3 times 1 to the 3rd power. X, 3 times 3 is 9. Y, 3 times 2 is 6. And Z, 3 times 5 is 15. And then we need to simplify this part. So the actual answer is 8. X to the 9 y to the 6th, z to the 15th. 8 because 2 cubed means 2 times 2 times 2. So 2 times 2 is 4. 4 times 2 is 8. Okay? So here's an example for you to try. Okay, so try that example. So pause the video, try the example, and then play the video so you can check your answer. All right, the answer is x to the 8th power. You don't have to write this step 4 times 2 unless you think you need to. Another example for you to try, again, copy it down, pause the video, and then play the video to check your answer. Okay, pause. Hopefully you've already finished the problem and you're just back here checking your answer. Again, 3 cubed means 3 times 3 times 3, which is 27. And that's the answer. Hopefully you got that right. And one more. All right, pause, try it, and then play the video to check your answer. All right, and again, I hope that you got that right. If you are looking at this, you don't necessarily need the 1. The 1 is an option. I just wanted to use it to show you how it would work. All right, I'm going to stop this video. There's another video where I explain more difficult problems. So stop this one and click on the next one, which has more difficult problems.